Okay, good. So here we go. Now it's up to you guys to work. So we are going to do like a small project. The goal of the project is going to implement a trait, which is more or less implemented, taking generics, and you will need to implement two data structures, simple ones, one being a FIFO and one being LIFO, so last in, first out, and first in, first out. Using this trait, at least implementing the methods in the trait. So you will have to use most of the things we have seen so far. So the traits, the enums, you will have to use option results and of course defining structures. So intentionally, I will let you work a bit and I will be there to help you in any troubles that you have. So yeah, and I will do the correction maybe in half an hour or something like this. So don't hesitate to ping me, the guys remote, if you have an issue. We will try to do the possible, yeah, without seeing your code. But yeah, that's what we are going to do, or you are going to do. Just a small precision for the put. I wanted to return an error in which condition? Why? Okay. Actually, this is not mentioned, but yes, I want it like the Q and I mean the LIFO and the FIFO to have like a fixed size. So so that the isFull should return true if we reach maximum size. And of course, when you are trying to insert something into a structure that has no space anymore, you should actually return an error. And that's what you will have to put in the error enum. So up to you guys. So one hint, you have to use a vector for holding your data. And don't cheat. Don't use AI. Don't use AI, Andras. I saw you. I saw you. He has implemented the stuff in 5 minutes.
It's beyond our control. It just
Come on. Word.
just
Because I just do this. Ah, right. Yeah, and it does this. Oh. But
It will not always work, Andras. It will not always work.
it stopped working and you go home.
What's the purpose of the width capacity function?
It's to create an instance of the structure with a given capacity.
Okay.
Like the size.
Yeah.
But the type vector is a continuous growable array type.
Yes.
So it's not.
But if you fix like a limit in your structure and you say I don't go above that limit,
You can do that with a vector.
No,
Say,
but if the function, like for example, pop or
we
add.
define the capacity for
Yes,
the vector.
Yeah,
Okay, okay.
if the function puts try to
To
look
go.
for the size before adding something, it will not.
And after that, we will write the tests to test our data structure so that you will have an idea of how you can implement unit testing for your Rust code. And this way, I think you will have a good idea of at least what a really simple library or module should look like in Rust.
Like the to-do macro.
Pardon?
The to-do macro.
Yeah, you have the to-do macro, yeah.
Yeah. That way it looks like I'm finished
Yeah.
because there's no linear or anything.
No, but if you reach a code path that reach to-do macros, it panics.
All right.
You have another macro which is unimplemented
Mm.
that does exactly the same. When you reach a code path that reaches the unimplemented macro, it panics the program and says unimplemented code.
Mm.
This is placeholder for, but yes, to-do macro and unimplemented exist. Is this okay? Anyone having issues? I mean, I just like created the skeleton. I mean, it's not something, it doesn't give any answer. This is just clicked on auto-generate the functions. That's it. There is nothing interesting on my screen.
Oh, there is.
Ah, there is? Okay.
Stuck on the first one with implementation of Q4 LIFO, the implementation with the generic ones.
Okay.
I missed the generic there.
Yeah, this is because it's a generic trait.
Yeah, yeah. Makes
Uh,
sense.
Is you, I see
Yeah, no, I
Ye-
try to.
you're having troubles.
Yeah, it's because I try and I don't know exactly how to do things.
Tell me.
This needs to create an instance
Yes,
of this,
yes.
but I don't know what to put.
You can use the constructor vector, which is vector some column new, and that's it.
Okay, nice.
This you can use, or you can use the vec macro, which is sometimes used to create vectors, and it's like a small vec bang and square brackets. And this actually creates an empty vector.
Okay.
And if you want to put values, you can put it here
Yeah, okay.
inside.
Okay. Okay, there.
Yeah, there are lots of like new is almost like empty constructors for many types. Andrea, Raphael, all good or having issues?
Yeah, getting the fitting around. It's fine for
Okay,
now, I think.
great.
No, I'm having some issues because I was not able to follow completely the trait chapter. So I'm just trying to improvise.
All good. And yes, if you are, especially if you have like stuff popping up and you don't understand, don't hesitate to ask because yeah, it might just be frustrating to be there and waiting for something you just don't remember or you don't understand.
Yeah.
It's as quiet as during an exam.
Yeah.
Probably gonna get very hot in a few minutes.
I will give you grades after.
More like nightmares.
No, no, I'm joking. Hey, you know, that's one of my recurring nightmares, being back to school.
Yep.
Yeah. I think that's
Either you haven't
Okay, I'm not alone.
studied an exam and you haven't studied, or you don't have pants.
My cat ate my homework. You won't believe me.
No, no, think back. Whenever I didn't do my homework or I didn't study exam, I should have like removed my pants, and then they will also like the teacher will just focus on me not having pants, and then they'll send me home or something.
Mm. Tizio, having issues?
Yeah, I try to understand what I do, but trying to return,
Okay.
but it says it's an integer and not a T type.
Okay, yes,
That's-
that's normal.
Yeah, but I should return the position of the next.
It's not the position, it's the item itself.
The reference of the item.
Yeah.
Okay. Okay.
So one hint for that is the vector type has a method, and many containers have it, is get method that returns exactly the type you want. So in theory, you should even don't need to call self empty before,
Oh,
and you just have to find a good index, and it returns an option reference T. Basically, it's just the index that you have to find.
yes.
So yes, peak is like a, in theory, it's not in the trait itself. This is something that we find in many iterators in Rust. It's a way to access the item of the iterator without consuming the iterator, which is pretty interesting in some patterns. I see red everywhere.
It's annoying. I'm trying to go put on the FIFA.
Okay.
It's,
You are testing out?
yes.
But there you are, you cannot like run code without being in no code block, so you have to create. Let's do like that. You want to test?
Yes, yes.
Let's build the test skeleton.
But I think
So you have to do that. You cannot run code inside nothing basically. So
I'm inside the function.
you're inside the
Yes,
function.
I have an X function and I wrap the entire thing.
Okay.
So that should work.
Yes.
And this
this
part
should work.
works fine. So I can create it, I can test it and it's indeed empty. But when I try to use put,
You don't need to put a type here, and because there what you do is that you are actually calling it like a static method. You have to use test.put,
okay, I see. Okay.
and you remove test, and you put just the item you want to
yeah,
put.
okay, and just Still not there. Still not there.
because there you are trying to reassign test.
Okay.
First, it's not mutable, and
So
probably you just don't want to. Why do you want to reassign put
Yeah.
to your FIFO? Because put doesn't return a FIFO anyway.
So it should be.
It should be like that. And why is it complaining now? Because it's not mutable, and you try to put something into something which is not mutable.
It's mute or what was it?
No, just mute.
Just mute. Okay.
This works.
Cheers.
And you can
And
do
then I can
unwrap
print
on it if.
True. So
So, oh, sorry. If you guys want to test out your stuff and you kept like this structure and not went like Andras creating it into a function, you have to define a module, which is called most of the time is test for tests. And you have to put a conditional configuration macro. This is conditional compilation. It means it's going to run that module only if you are running tests. You have a lot of conditional compilation in Rust that you can basically configure and set. And one is to run test, and it checks that it's running in test mode. And if it's running in test mode, it's actually generating this code and executing the tests. And the way you define test cases is like test, I don't know, with capacity. You create a function and you have to put a derived macro, a procedural macro call on top, which is called test. And this is basically how you create in a library, in some piece of Rust code. This is where you should put your tests. And this is going to be compiled and run only if it's in test mode and will never reach production code, of course. Thanks to this conditional compilation directive. So yes, conditional compilation is very powerful because this is just for tests. But for instance, you can define architecture-specific implementations for functions, for types. You can define a system, so operating system specific implementation. You can do a lot of things thanks to conditional compilation. So I'm going to start implementing the LIFO. So last in, first out, we are going to use a vector. Let's call this
Elements.
Q. Yeah, whatever. Which is going to be a vec T, right? A vec of type T.
And you need a size also.
Not really. We can, in theory, rely on the vector's capacity. It should work. So self Q, we do a vec with capacity and we put cap.
Since cheating, we don't know all the the function of each.
You could do that, or you could like add an additional field, which is capacity, create new, add stuff. It works. So let's start with the first and easy methods. Is empty is easy.
If you check if the len is
Self dot q dot is empty.
okay.
Is full is not much complex. You do self.q.len. No, because the vector is never full. So since it's like continuously growing, so we have to find like a way, and the way is like you have to check that the length is the actual number of items in the vector is equal to the vector capacity, and in this case we say it's full, right? The capacity is the number of items the vector can hold, and the length is the number of items currently inside the vector. So should be that equals self.q.capacity.
Or we can say supérieur ou égal. No. Better?
Yeah, but it should never be greater, right?
Yeah, good.
You can, but it should not. So let's decide how to put an item.
It can if we call 2 times put without checking is full or not.
Yeah, but this is a programming mistake. Because input, you should return an error if it's full.
And input we should call is full or not, to check if it's full or not before calling, before adding.
Yeah. So self.is if, let's return an error that we have defined. Q full, is that okay for you? Yeah, we could even put full. If we want, we can even put, this is just for the purpose of saying we can put stuff in errors. We can put like the number of items, or we can put like, the capacity basically, because anyway, the length will be equal to the capacity. So there is no purpose of putting both values. So let's return an error variant name qfull and self.q.capacity. Yeah, we can do like that. I prefer instead of having nested else elf. Then what do? We put the items, so self.q.push item, and results should be nothing. So the pop method should return an item that we want to pop out of the LIFO, and so the last in should be the first out, so the last value we pushed should be the one we pop. So should be self.q.pop, and that's it. Because yes, many of the methods we want to use already kind of exist on vectors. This is good. So only the peak method is leaving, and maybe the trickiest one.
For pop, we don't have to check if the queue is empty.
No, because actually pop removes the last element from a vector and returns it, or none if it is empty. So the vector implementation of POP is already a good one. So
Pure one.
yeah.
Yeah, and since we have the return type is option. It's good.
And a peak, so we should get basically a reference to the item we want to pop, but without popping it. That's the idea. So the last item, actually, this is easy. This is even easier than I thought. It should be this.
Return the last element of the slice.
Yes.
But it's not going to. Yeah, it's not going to pop it. Okay.
No. So this is like the super easy implementation. Tizio, I guess you went on something like self.q.get, but I think Clippy will complain if I do that. If I do self.q. Yes, len, don't forget to do -1. But you will complain and will tell me, bro, you are dumb, utilize q.last. Right? That's what it says.
Yeah, try set plus Q.
So even if you try to do this implementation, it tells you use just q.last. That's what you are doing, actually. So here we have our LIFO implemented. And you see like there's not a lot of code. Pretty easily thanks to all the primitives that Vector already offers to us. And this is what is actually nice with Rust, is that it really gives you a lot of primitives on all the basic types, and just creating custom data structures around existing ones is super easy. So now we can somehow test it. I will just do test LIFO.
And is this is the vector safe for multiprocessing?
This will not work in multiprocessing. If you want to multiprocess, you will have to put some mutex in place, some mutual exclusion patterns in place. So this is not safe for multi-threading. And actually, if you try to use this multi-threaded, like you will get red everywhere, the compiler will just not compile it because it will require you to implement some sort of mutexes. This will even not be possible to use this structure as a multi-threaded. But for instance, you could actually wrap this structure inside a mutex or something like this. This would be maybe the pattern to follow if one wants to use this structure in a multi-threaded context. You would use something which is called ARC, an ARC, asynchronous reference counter, and this way you get some kind of read and write locking for your structure, basically. But you will see, like, what is interesting with Rust is that you actually use multiprocessing only when you actually really need it, because Rust is already fast. So most of the time running in single process is acceptable. And in many other languages, you want to multiprocess because it's slow, like in Python, for instance.
Is it going to use all cores from the CPU?
No, it's not going to use the whole core, but I mean, running in one single process is already super fast. So most of the time, I mean, it's because running in multi-processes, it's some kind of some overhead, so it needs to be justified to run in multi-processes. And since like stuff are already very fast in single thread, You just multi-thread it when you have a really strong need to multiprocess your stuff.
Yeah,
So,
like for bigger structure anyway, I always use Redis as like shared memory and then use my multi-processes that just like I let Redis deal with the whole like managing the data state across processes. Like Redis is a single thread thing and everything else runs multi-processing and that's fine. Generally
yeah,
just
this is an
easier
option.
anyway.
Yes.
Yeah.
This is an option, indeed. But yes, Redis might be like slower than just having a shared structure directly
Oh,
in memory.
absolutely.
But of
I
course,
mean, sure.
but
Yeah,
of course,
it's just
it wouldn't. It wouldn't offer the multi-threading across machine that Redis would offer, of course. Because you can have this additional possibility with Redis is that you can even like spread the load and distribute, yes, across machines, while multiprocessing on the machine with shared memory it just stays at the machine level.
Yeah.
So here we are for the implementation. For the test, so this is really the way this is something you have to remember. You have to know this is the way you implement test in Rust. This is always the same. Everyone does it. So mod is a way to create a Rust module. See, this is like almost the same as creating a file which is called test.rs. This is considered as a module too. And config test, again, it's conditional compilation, compiling this only when you are running tests. And if you do like conditional config like this, you will see this little play button that will appear, and then you will be able to run your test from VS Code just by clicking like that, which is pretty convenient. You can even run tests one by one if for instance, you have one test case which is broken. You can just like investigate and fix and run the one concerned. So let's test our LIFO. We create a new one with capacity 10. Okay. Let's create a LIFO of whatever, of I32. This is one way to annotate. We could like put it here, LIFO I32, and remove this. If you prefer this notation, this is the same. Or we can just, as we said and as we have seen, use L dot put and say 1, for instance. Yes, I have to put it mutable. And if we, if we do that, we don't even need to specify the types because of type inference, as we have seen since the beginning. Okay? So just after the creation, before we put something in our LIFO, LIFO should be empty, right? Assert.ec L dot not assert ec, but assert L dot is empty. Okay? So first test. Then we put 1 in the LIFO. We should assert that this is okay. Is okay just checks that the result of put returns us an okay value, so there is no error, right? We should not have any error because the capacity has not been reached. Basically the LIFO is not full. Okay. If we do L.pop, actually here we do assert ec, it should be some 1. Because why it should be this? Because we have put 1 as value as first item in the LIFO. Pop returns an item. There is only 1 item, and pop returns an option, and we can directly test if the result is sum with the value. This is equivalent to destructuring, basically. You can see that as destructuring notation, as we have seen in previous chapters. So this, if I run, should be fine. If it's not running, we have an issue. Okay, all good for the moment. So let's try to assess the... Yeah, we could have tested the peak as well. We could test the peak. So assert L.peak. And this should be sum. And here we can cheat and we can use this notation, which might be very confusing for the people coming from C. It caused me some issues in the beginning. You can directly test that the return value is actually sum and a reference to something which is 1. Okay? This might be confusing notation, but it works. Here, the test should still pass. Okay, we good. So now let's check our peak. It's done. Pop, it's done. The put and is full. So L dot put 1, 2, 3, 4, 5, 6, 7, 8, 9. Why are you complaining about? Okay. We could do this in a loop, huh? Of course. I do it like that so that it's very clear what are the data in the LIFO and the order they are. Here it's safe to call unwrap, okay? Okay, why are you happy? What needs to implement derive? It's the error. Error needs to derive debug, okay. Unwrap. This is okay again because we are in tests and we don't care if our tests are panicking. It's actually good to know if a test is panicking because it's not expected. So now we have 9 values in our stuff. Actually, I could put even one more. And now if I assert that L dot put 11 should be an error, right? Because we have reached the capacity of the queue. Let's try if it works. Okay, the test passes. So our put method works correctly because we cannot go beyond of the capacity of the queue, which is 10. And now we should be able again to pop. And so the last in should be the first out. So we should pop the value 10, right? We can even test with peak that we have 10 value before and then pop 10. Okay.
Can we create a for loop?
With this,
Yeah, to
yes,
simplify.
we could. So
Actually,
we
I would
can
test
create.
sorry.
Yes, Andrea?
No, I just wanted to create also test for is full. Otherwise, can be a false positive the error if is full is not implemented.
Yes,
in the
that's
correct way.
true. We forgot to do it. I will do it straight after. Thank you. So we can do that. So we can use the range.
And maybe create a variable capacity to reuse for the for loop.
To change. Yes, we could do that. If you want like to test with yeah, but anyway it will change like all these values, so yeah, it's gonna be a mess. A small note about the Rust tests. Most of the time they are really simplistic like that. There are a lot. There are more. The idea is more like having a lot of small and very simple tests rather than big tests complicated with variables and so on. Most of the time they are just like with fixed sizes, with known values and so on, so that you look, you can directly see what's the point, instead of having loops, initialization, variables changing, and so on. Really, the tests are very, very simplistic in theory.
Shouldn't each assertion generate output?
Pardon?
Shouldn't each assertion generate output?
No, assertion don't generate outputs.
Okay, so when you run the test, it should. No.
So we could do that to simplify and remove that. Should work too. Yes, it works. And now we should do the assertion test that L dot is full. That's true. Thank you Andrea for reminding that we didn't test this function. Okay, it works great. Interesting thing that you can use ranges like that. And now you put a closure here. This is something else. What the issue is. Expect one argument. Yes, of course. Okay. If you want even shorter code, you can do stuff like that. This does exactly the same as this. Actually, for each, this is something which is implemented for the iterator trait. So if I look in the documentation, yeah, this might be also a good iterator. Okay, and show 76 methods. So these are all the methods which are directly implemented when you implement the iterator trait. And one of them should be for each. And every time you have an iterator, you get this method to iterate over it. And yeah, bunch of functions that you get. And here, the only method which is required for an iterator is next. And out of next, they generate like 75 methods that you can use for a iterator, which is pretty nice.
Can you show me, because one of the things that couldn't get to work is actually raising there. So if I try to go above the 10 limit, I will expect it to raise an error.
Yeah?
No, below in the actual test. So you do 1 to 10 for the range. Okay, you have that. It works for me.
So there I'm checking that if I put something while it's full, I get the variant of the result enum is an error and is not like the OK variant. Because if we remember, the result enum has two variants, either OK and either or error, which is for errors. So it tells you returns true if the result is error.
I see.
I'm confused about something.
Tell me.
Okay, so first question is sum 10. What does that mean?
This?
Yeah.
This is the variant of the option enum. The option enum is either known or sum. And this method returns an option of a reference to type T, and in our case, T is I32. So we should expect the results of this method should be either none or is a sum with a value inside.
Okay.
And here the value we are actually expecting is a reference to number 10 because this is like the implementation of this method that is supposed to return a reference to the last item in the queue.
Okay.
And the last item is 10, so we should get a reference to something which is 10.
Okay, what are we expecting from that row, the 99 that we expect?
What we should expect?
Yeah, do we expect? Okay, it asserts if the last value that from peak the value from peak is 10.
Yeah.
Are we expecting it to succeed? This to
Yes. Here assert egg is we should assert that this is equal to this.
Okay, because of line 95, or we put that
because we have added items from 1 to 10 in the queue, and our queue should contain all these items 1, 2, 3, 4, 5 until 10, and the LIFO is popping always the last in. So the last in is 10, and here we want a reference to the last item, and the last item being 10, we want it to be 10. So if it's not equal to to 10 here, it's gonna raise a panic here. So our test is failing. We can try if we expect, I don't know, 1, the test is going to fail.
Yeah. Yeah, I think I just confused myself because I was just adding ones. I just added lots of ones.
Yeah, so here if you added only 1, I mean,
then should all
you should be 1 here.
yeah.
Here, the only thing is that we expect 10 because our last item was 10 in the
Yeah.
queue. So that's it for the LIFO. Now we have made this one. Do you want to try to do the FIFO by yourself? Yeah, maybe it's gonna be easier.
Just copy paste.
Yeah, you will have to change maybe some stuff, but yeah, it will mostly be copy pasting.
Can I ask a question?
That we put
Second, Andrea, there is Nikki who is asking a question. I take your question after.
Yeah.
Good?
So each assertion is chained after another. It's not like a new thing that happens. So when you assert put 1. Okay, yeah, that's
Yeah,
expect to
actually,
1. Okay.
actually, this assert, you have to see it as this. This is exactly the same as this. If L dot put 1 is okay, or at least if false, okay, panic.
Okay, yeah.
This is what assert does. It checks that this is actually returning true. So if this is not true, which is equivalent to this, if this check is not true, it raises a panic. Oh.
Yeah, I was just checking that it actually happened. It's not like in its own scope. Okay.
Can I ask the question now? Or
Yes, sorry, Andrea, tell me.
no, because I didn't hear Nikki speaking. I unfortunately I didn't follow completely the trait lesson, but I was wondering, and I tried, but a lot of issues to implement with capacity and is empty in the trait itself. Is it something possible in Rust, or
This is not possible for the simple reason that at the trait level, you have absolutely no idea of what the structure is, right? So you cannot create a default function with the knowledge of the structure. You agree that with capacity and is empty and is full needs to know Q, right? So here, unfortunately, in this trait definition, there is not a lot we can do, a lot of default implementation we can provide. But indeed, as we have seen this morning, there are some traits where you can provide default implementation for methods. Here you cannot because, I mean, none of the methods uses the other one, let's say. So
So in this
Yeah.
case, if I would do something like this, I should define a Q structure that says that Q equals vector, and then in the Q trait we receive that structure instead of T, right? Or is it something strange?
I don't get what you want to achieve, but maybe if you explain me.
So yeah, I was just thinking loudly that if Q receives a generic that says that it should receive a structure with a variable containing a variable Q containing a vector. So in this case, if I know that this is a vector, I can work on the common functions, no?
Yes, you would know that a parameter is a vector, but then you wouldn't know that the member of your structure is a vector. But yeah, to be honest, the constructor, I mean, this is you cannot like provide a default implementation for a constructor because it makes the assumption you know already the layout of the structure. And since we don't know the layout of the structure, I mean, this is not possible. Because this we have to see like the trait is something we can expose in a library. So if I publish this library, I mean, everyone would be able to define and implement the Q trait with whatever, let's say, backend structure he wants. So maybe he doesn't want to use a vector, maybe he wants to use an array, maybe he wants to use something on the stack. I don't know.
Okay.
You see?
Okay.
So
And
since
then
we don't know like this, pardon?
And then what is the value to have a trait? Just as a contract.
Yes, this is a contract, this is shared behavior, and this is something, yes, you can rely to constraints on the generics as well.
Okay.
This is what you use in the trait bounds when you are using generics. So if you have no trait, you cannot constraints on the generics, and then it becomes a nightmare. Then you cannot basically use generics. So traits, yes, are pretty useful.
Okay. So at the end,
It doesn't mean that you should really, I mean, you should implement traits everywhere. If, to be honest, if this is pretty rare where you want to define traits because you can rely on the many traits already available in the standard library. But yes, you just have to know that that it exists, how it works, and the limits and what it's used for.
Okay, and in this case,
It's just like for the purpose of the exercise to have this Q trait. But if I would have to implement LIFO or FIFO, I wouldn't use a trait for that. I would just create structure with the methods without relying on a trait. This is just assuming we want like to use some generic function that needs to take a Q as a parameter. It can interchangeably work with LIFO and with FIFO, yeah, without issues, because both implement the same trait, which is Q. Is that clear?
Yeah, I was just thinking how to avoid to duplicate the functions. In this case, it's better to write another function that takes a vector or any Yeah.
I guess in this case, one advantage of using the trait for it would be you could use, for example, you move is empty, for example, in trait, the actual implementation, and then you would need to implement it in.
I don't get what you say.
Because there you could actually implement is empty directly in the trait.
How?
No,
No,
you can't.
no.
Okay.
Because as I said, the thing is that is empty and I mean all the methods here needs to be aware of the structure behind, right? And since it needs to be aware, there is no way that you can do anything here. For if we look at for instance the iterator trait, so here all these methods are working on top of this one. Okay, so these are all how to say are implemented on top of next. So that's why they can provide you and provide default implementation for all these functions. But yes, in our case, the thing is that all our function needs to be aware of the structure for which it's implemented. And that's why we cannot really provide, in this case, default implementations. I don't know, but could we actually provide a method?
I think we could if you had the vector directly in the trait.
You cannot have any structure in the trait. This is not possible. You cannot do that. What? No, there is not much default trait that we could provide here. Did you guys implement the FIFO without any issue? Did you test?
No, but you know that there is some.
You need to
tricks.
test.
Yeah, I test.
It works?
Yeah, because I use not vec, but
You haven't used vect?
I used vec
you
DQ.
use vec DQ.
Yeah.
Cheater.
It's pretty simple with the
because one
Yeah.
one suggestion was to use pop fonts.
Yeah. But what is nice is that actually, and I think this is good that you didn't use vec and you use vec DQ, is that with your FIFO implementation, let's do it with vec DQ, which is basically copy pasting and using pop front, right?
Yes, and just there's just one change. It's the first is replaced by font. Last is replaced by
Yeah, true. So vec DQ. Yeah, good. You have actually looked at the documentation and find that another structure was more adapted. Vec DQ. This is
font.
yes. Up front. And push back. And this is interesting because what we have done here, we have kind of provided like the same methods for two data structure which are baked with two different let's say, vectors implementations. So this is nice, I think. And it shows, one kind of realistic use case of all these like traits and generics. So yeah, good that you find VecDQ and you implement it like that. So now we could have, I don't know, a method that takes a FIFO or a LIFO. I don't know. We could create a function which is fn pop q. Okay, this is an example, and we take a generic type. We can call it Q because it's going to be a Q. We wanted to implement the Q trait, and this is going to be a Q, and actually we would do this. This works. Okay, this doesn't work. Cannot find time t. Okay. Should I do that? Okay. So q dot pop. Yes, I have to put a mutable q because popping is mutating the q, right? And this method, for instance, you would be able to use it both on a FIFO and a LIFO. So to come back to your question, Andrea, this is what traits are used. It's actually used a lot like to create a trait bounds and stuff to deal with generics, basically. And create implementation specific based on the traits implemented by the underneath structures.
It's like burning. Is everything okay?
It's what?
Okay, it's nice.
Are you okay, Raphael?
Yeah, sorry. It just yeah, it's fine. I thought I was muted. Never mind. Queen is cooking. All good.
Okay. So what could we talk about now? Something very interesting as well in Rust that may be interesting to mention right now, since we are creating some sort of real life code. This is like, to be honest, I think it's it's something that you could find in one of my projects. So I think it's pretty realistic use case of many things we have seen. Interesting stuff is in Rust, you can even control the inlining policies of some code. So it means that you can create very, how to say, fast code. And you can control if it's inlined. Anyone knows what inlining code means? So damn it. So inlining code, what does it mean? Is that when it's compiled, the code, in theory, I will simplify the thing, is you will get a call instruction, calling a function, and getting the results and continuing the process. This is like a function call, right? Inlining means instead of calling the function, I take the code of the function and I put it directly inside the code so that you get rid of that call instruction and inspecting the results. So for instance, if you put directive like this on a function, which is a macro, this function is empty, which is always a small function, will never be a function call, will always be inline in the code. And that's why Rust is like a nightmare for reverse engineers, is like because you have inline code everywhere. And because inlining is, of course, faster than having always bouncing back and call instructions and so on. So you can control the inlining of your function if you really want to optimize your Rust code. This is pretty interesting. You can say inline always. You can have inline never. So this will never be inline. If you don't want to inline your code, for instance, cases where you don't want to inline code is when you have huge functions. Because if you have huge functions that are going to be inlined at several places, it means your code will be, I mean, your binary will be super big. So yes, and you can just have something that says inline, which is some sort of prefer inline. But if the compiler decides there are too many calls to the functions, it will not inline it. It will inline, let's say, only if it sees that the function is used maybe once or twice and is not too big. I cannot explain you the exact strategy of the compiler because it depends on several aspects. It's like what it calls the it attributes some weights to the calls. Let's say if it's a hot cold calls, meaning very frequently called or not frequently called. And it also attributes weights on the function based on the size of the function. So it's pretty complex stuff. If you're interested into this, you look at the LLVM code, but you don't want to do that. So yes, this is something very interesting you can do. And sometimes just inlining a really strategic function, you can gain a lot of speed in your program. You should not inline everything because, and especially in library, if you develop libraries, you should inline, let's say, not a lot because it would mean that all the people using your library will have like a lot of inline code. So you should only inline strategic functions, let's say.
Also, if we have a lot of calls of a function, you probably don't want it.
Yeah. In libraries, what you could do is eventually this, just say inline, preferred inline, let's say, but don't like always inline. Always inline, maybe it's better if you just use it in your final binary or stuff like that.
If you don't put inline, it will never inline, or the compiler will decide.
Let's say if you don't put inline, it's preferred not inline.
Okay.
It's not means it's not going to be inline. There is still a possibility that it gets inline, but it's more in favor of not inline. Inline, you have to see it, it's more in favor of inlining. Inline always is like always inline, and inline never, it's never inline. And even I think inline never and inline always on the extreme parts, if you put inline always and it sees like your code is used everywhere, maybe it will not inline it just because it would create a too big binary. But yeah, if you have inline always, you have like high chance it's going to be inline. And if you have inline never, you have high chance it's not going to be inline.
How do we how do we see, how do we know what the compiler decides to do?
You don't know.
Okay.
You have to read through the binary maybe.
Yes, you can reverse the binary. Maybe there are some messages that you can get out of the compiler. Probably there is a way to know when it's inline or not.
Use cases, concrete.
A concrete use case of inlining, if you want to gain speed on your program, and
You cannot put it everywhere.
No,
So in which exactly cases
you need to put it in very strategic functions that you know that they are called like maybe a lot,
Wow.
and functions running in loops or stuff like that. Maybe you just want to inline it in the loop, and
inside of the loop, right?
yes, inside the loop, and so that it's getting faster. If you have like a high-paced API call or something like this, and maybe with a bit of intensive computing, you want it to be inline. Yeah, this is a bit of feeling, when you start to know your program, and you can even benchmark your program. Yes.
We can benchmark it. I mean, is
The-
there any like internal mechanisms to do?
There is no
Inside.
internal mechanism. There is one tool that you can use. So something we have not talked about is Cargo, and Cargo is some sort of Rust package manager. And you can install like a lot of tools and even Cargo utilities. And one of them is Cargo Flame Graph. And you just install it like that. And with this, you can actually benchmark and have a flame graph of your program. We can look at it, Cargo Flame Graph. What does it give? Probably there is a page. Yes, you get this kind of stuff. And it basically creates you interactive SVG, where you can actually select the parts of the code and investigate the percentage of resource it's taking. Maybe there is one here. No, they don't.
So we can simply add inline and see, okay, if the performance is increased, if the memory is reduced, whatever. Normally it's increased, right? Because the function inline, it means that it will be.
So this is like an example of a flame graph, Cargo Flame Graph gives you. So here are the like more resource intensive. Oh, damn it. What happens? Okay. These are the most resource intensive function. This is main. After that, it's pthread, blah, blah. And maybe it starts to be interesting. Maybe looking at here, we see that this function like takes a lot of time, or okay, in theory we can click on it and it's zooming. Okay, it doesn't want to zoom.
You have too much SVG.
Yes, maybe. So actually this is very useful. One other thing which is very useful to benchmark performance, it's called Criterion. This is a benchmarking suite for Rust. So this is like you have to create your benchmarks and so on. And once you have created your benchmark, you can rerun it, and it will like compute the gain or the loss that had compared to the previous iteration. So this is very, very nice. Yes. This is like a super nice suit that you can use. And you have to define your benchmark in your cargo file. So maybe on Monday, during the remote session, I will present all that, maybe a bit of project management of Rust. So how to kickstart a project, how to install dependencies, how to maybe organize it a bit, so that if you want to start something, you don't get blocked on such trivial stuff. And after that, maybe we can address your own questions and concerns and stuff you would like to dig more into. Just maybe if some of you have specific questions and specific stuff they want to see on Monday, just email it to me, and I will prioritize it. So far, I have the request from Raphael asking for creating Python bindings, which is interesting, and I think this is not very complex compared to what we have seen. This is just using some Rust macros that are already defined. So nothing very crazy. And yes, you had the DB question, but
or just a default set of frameworks and so on to decide the recommended ones.
Okay, we can do that. And if you have specific questions on
working on sockets.
Okay, we could see that how to work with sockets. I mean, this is not something very complex. This is just going to be system specific, so it's going to be specific Linux programming. But I mean, yes, we could have a network socket example. Or what are you interested in? Basically, more HTTP, higher level HTTP more, or really raw socket? Raw socket level. Okay. Okay, raw socket. I don't say I will address everything. We will try to do the maximum. So yes, Criterion is nice if you want to benchmark your program, and especially trying to improve it via some tweaks in the either in the implementation, in inlining strategy, and so on. This is something I've used in several projects. It's nice. I think there is other frameworks, but this one is very, very nice. And you see, it gives you outputs like this. This is not very. What could I do? Yeah, but this the guys remote will not see. Maybe I will try to look into one of my projects. Maybe this one. Maybe the benchmark are broken, I don't know. Maybe it's not going to work. Yeah, that's how Rust works. It downloads alpha every time.
JavaScript or anything.
Yeah. Just a bit, but I kind of hated it.
And Java?
Java is my biggest frustration in my computing learning. Yeah, this is where I started Java. But since I quitted the university, I've never used Java anymore.
Typical universities.
Who uses Java? Come on.
In the university.
Yeah.
Just used, let's say, not used. No.
Who programs in Java? Okay, this is like benchmarking, one of my stuff. And this is what it tells you. So I have like 2 benchmark functions, or maybe more than this. Yeah, basically I'm like benchmarking input outputs based on one structure I've implemented. So this is like the first iteration. So it gives you like the average function. You benchmark the average time per function and so on. And if I rerun it, it's going to create like it's going to do it again and tell me like the difference between this iteration and the previous one. And look, but there it's not significant because I didn't change anything in the implementation. But yeah, it should be around like I've seen should be around 0 to 5% difference when you don't change the implementation, and it starts to be significant where you reach like 10%, or yeah, this is weird, for instance.
So there it says high, severe, high, mild.
Yeah, it tells you performance has improved, but I didn't change anything.
It seems like the criteria it's using is quite like it's still like in the domain of less than 10 milliseconds, and yet high, severe. I wonder what its scales are.
Whether that's scalable?
But no, I mean, like if like it says high, severe, like how do we like? Does that mean that your code is badly optimized, or is it just like relative to all the results?
This, to be honest, I don't know what it means. Maybe it's just like found 2 outliers. That's what it means. There are 2 high severe outliers. I don't know what means. Outliers, probably these are the ones which are not taken into account into computing this.
Okay, yeah.
That's what it means.
Anomalies and stuff.
Outliers, I think they explain it. Maybe we should go back to the stuff. Oh. Maybe they document it somewhere.
Goals, maybe?
Yeah, goals. No. We don't know what are the outliers. Okay, maybe this is like their documentation. Where it should be a search somewhere.
Because I'm thinking like the goal is to identify inefficient code, but the results we get are.
This is not like to identify inefficient code. This is to benchmark your implementation versus eventually modifications you do in your code.
It was in the goal. It was written in the goals to find.
To find what?
Well,
an efficient part of code.
Yeah, something.
But it's not going to tell you that
Yeah.
something is inefficient.
Yeah.
What it does.
What I don't see, yeah. Maybe it will help you to really benchmark the part which is slow, but for me to find what is slow, you have to use this.
Yeah.
First, already you find like what method is slow, then you benchmark it, and then you try to improve it with the benchmark.
Yeah.
But I mean, finding the one that is slow, for me, this is not like the purpose of criterion. At least it's like validating this is the one which is slow, and improving the one which is slow. But this is more like the one approach that should be used to identify like the slow functions.
I think the other thing is just variance. If function, because it runs every function 100 times.
Yes.
So if you had outliers, and that means that the stability of the performance is not there.
Yeah.
So that there are cases when the performance goes up and down.
So yes, these are the two tools I'm using, like to identify performance issue, to benchmark implementations. What else? Cargo. Yes, there are some cargo tools I'm using. Maybe I'm going to mention them on Monday, because one thing which is very, very interesting in Rust is that, for instance, in a project, you can define the README inside the library. And there is a tool which is called Cargo README, and that extract the README from the documentations. So, and you can always have also the tests in your README, which are executed when you test your projects. So even in your README, you're always sure you have working examples, which is very, very nice. And we could do this just as an illustration. Yes, that's time almost. So these are the create comments, create level comments. And if I put example, I put Rust. Yeah, don't even need to put Rust. And I put some, how did I call this create project? Okay. Use project. And what was LIFO? And let's take one of our tests. So, and this should run when I do cargo tests, not the one I do when calling the stuff in the module, because it's just running the module. But if I go into the terminal, okay, it's failing. Why? What the hell? Consider changing function, or is not found in LIFO. Okay, because I didn't import the trait. So use LIFO and Q. No function. Demit. Trait Q is private, of course. So it cannot import it publicly because it's private. So I have to put pub. And now private type. What private type? Error is private.
And you don't need
to. Maybe yes. It is already.
Okay.
Okay, it works. And look, here it tells me that it tested something at line 9. It's like doc test. Doc test means it runs the test which is documented, and it's running that. So if I put like something that is going to fail, so if I just do is error, which is going to fail because I just reversed the test I'm doing, I will have my cargo test failing. So this is nice because you're always sure that your documentation is validating your tests, and you can even, thanks to what I just mentioned before, cargo install like this, I guess it's. This is the one I'm using. Probably there is another one. Cargo install. And this generates a README out of this create comments that you did here. So if you start to mix everything in your CI/CD pipeline and so on, you get really efficient and reliable READMEs, documentations, and so on. And that's very, very nice. Because yeah, that's been something, an issue I've been facing in many other languages, that examples are not working. They are not returning the proper exceptions, the proper stuff. And yeah, at the end, it becomes a nightmare. You just want to throw your laptop away. So just let's see. And actually, this documentation can be done as well on at method level. So you could have examples like this. Let's say this is like an example for, could be an example for isEmpty. So isEmpty LIFO, I could create a method. So the documentation with the bank is the one you should put at the library level, at the crate level. We don't speak about package in Rust, we speak about crate. A crate is supposed to be smaller than a package. And this is like actually the documentation for that function. And look, you can even like run the doc test from here, and it will just run that one. So, and this, when you get your crate published, it's going to generate the documentation and everything for you. So you say this method checks for, I don't know, LIFO emptiness. So this is nice. Just show you the cargo README, and we can leave, I guess.
So with this, basically, you have the tests always in the same file as.
Yeah,
that's cool.
As the documentation. And but yeah, what I really like is this is okay. You get your function, the function documentation, an example use, but you know that this damn example is going to work. It's not like, oh, you have an example here and no one ever checks it and ever checked that it still works after 10 years of modification inside this method. You know that if, again, the people who are developing this crate and publishing it, they have like a proper CI/CD, and this is now, I guess this is very easy. It's just basically in your CI/CD is what? It's just cargo test. And cargo test, boom, in my CI/CD is like cargo test, cargo Clippy, and maybe that a few other things for custom projects, but that's it. It's not very complex to put in place, no specific stuff to install. the cargo README, this one I'm going to install is nice too, because you can even check the README is up to date with the one you have defined in the code. So you can check for README updates, for instance. This is very nice. What else I'm using? Cargo README, cargo. Yes, one important one is also cargo release. This is something that is very nice for managing the versioning and so on of your crates and the publishing. It does everything for you. It bumps the version, the patches, and so on. It pushes to Git with the proper tagging and almost nothing to do, just cargo release and that's it. So cargo RDME, it's going to complain. No README file. Touch README .md. Okay, it's going to complain again because it wants this to be a tag inside the cargo README. And okay, I will add it manually. README. What the hell?
Maybe
Vim or nothing.
Don't use them.
No, nothing.
Emacs.
What?
Emacs.
What? Okay, it's gonna be faster like this. And now, shut up. Boom. It takes the library. You can do, even I can modify here. It tells me if I do cargo README check, tells me it's not up to date. So I will force it again. So now it's okay. And same if I modify the stuff here. I don't know.
So the documentation for the function that you added is not in the README.
No.
Yeah.
This is there, tells me it's not up to date. I want to update it. Force is just like to bypass, like because it's not generating if you have like a pending commit, I guess. You see uncommitted change, that's why I'm using force. That's very interesting. And yeah, for the documentation, you have to use cargo doc. This is like built-in. Why it doesn't open? Did it open? Yes. This is basically giving a view of what is going to be. Actually, when you publish your crate on crates.io, they have their own cargo doc running, but this is just if you want to see an overview, local overview of the documentation that it's going to be generated. And I documented like the LIFO examples, and this one, as we saw, got tested, and we know that it's going to work. So yes, as you saw, Rust is not like only just focused on development. I think all the things around like project management, like documentation, and all of this, I think this is a very nice ecosystem too. and really makes your life easier than in several other programming languages.
Did you show us like a shortcut to generate function documentation?
To generate that?
Yeah, for function, for example.
To generate what? To generate you want the documentation or just
this type of
this?
Yeah.
There is no shortcut. It's just like I mean, you can ask a LLM to document your functions. It works pretty nice. But you can say, okay, this is putting an item into the LIFO.
Because I think in Python you have like extension or shortcut to easily generate this type of documentation based on function definition, like output.
Maybe there is. I don't know everything. So at least I'm not using one. What I do for function documentation, most of the time, I just prompt LLM and ask the LLM to provide me proper documentation and example code for the functions. If you provide like the function prototypes plus the tests, it will manage to create something for you. So, and create examples like this. So, and in the end, you just want the example to run. You don't really care if it's okay. If it's completely fucked up, you have to correct it. But at least it's a good entry point, I would say, for documentation. That's about it. About really just code the documentation and small tools around the ecosystem. So we have covered benchmarking, performance tuning. Yes.
Did you use Axiom?
No, Axiom. No, I didn't use. This is a web server, right? Yeah. HTTP web server. No, I didn't use this one. I used the Rocket, which was an alternative to Axiom, but Rocket seems to be dying. So Axiom would be the one I would go for. So yeah. And again, Rust has made the choice to have like a lot. I mean, the basics really, the foundations really strong in the standard library. So yes, all the HTTP implementation and so on, you will have to rely on external crates for that. And yeah, up to you to choose the one that you prefer and according to your preference and what you are looking for. I wouldn't recommend anything for the moment, except just for database management. We have discussed with Andras, and I've been using something called CORM, which is pretty nice. So it's a ORM framework for Rust. This is pretty nice stuff. Pretty straightforward and reliable. There are others, of course, but this was the one I liked the most. I kind of benchmarked this one and a Diesel, which is another one, and I prefer this one. So yes, for every single applications and very specific, I mean, stuff you want to do, you will have to find a crate for that. And maybe build your own if there is none, because sometimes it happens. So
I'm just investigating also YEW.
YEW. Yeah. So in my experience with developing front end in Rust. It's complicated because all the time it needs to recompile like the front end and so on. And it's, to be honest, it slows down a bit the development process. I don't know if there is, I think there is something called Dioxus as well to do front-end development, which seems to have like hot reload functionalities and so on. I've never tried it, but so far I did one UI applications, and what I did is just JS as a front end and Rust as backend. And I actually embed the JS in Rust, and I'm serving the JS inside from the Rust binary, which is embedding an HTTP server based on not Axum but Rocket. And yeah, it works pretty nice. And development in JavaScript with Node.js, Vue.js, and whatever is like super straightforward. So yeah, that's what I've been doing. I know that other people develop front end like that. I mean, web front end. So they rely on an API implemented in Rust, serving JSON, and just like rendering with Vue.js, AngularJS, whatever graphical framework you prefer. It's pretty, to be honest, it's nice. It's pretty nice like that. So you are really confident in the backend, and then the front end anyway, you don't
But
really care.
maybe it will be faster to develop an API in Python than in Rust. No? Or
yes, probably it's faster, but this is always the discussion between Python and Rust. Is for me, okay, Python is really fast to develop small code and really low function code. But when the project starts growing, the issues are coming. Because when you have to refactor, when you have to change APIs and so on, at some point it's breaking everywhere. So, I mean, that's my personal experience with Python. It's Rust, you spend time developing. In Python, for me, you spend time debugging. So this is like the difference between the two languages. Python, yeah, Python. I just every time I develop Python, I did Python like for 10 years, so I'm not like speaking just like that. And you think I'm a Python hater? It's just like Python. When I write Python, the first time I run the program is with PDB. You know, is if I don't run with PDB, I know that it's going to crash somewhere, and I will not be able to investigate. So every time I start a Python program is with PDB, and yeah, always debugging, even the first iteration of the program. And yeah, for me, it's a lot of debugging Python. But yeah, again, Python, I find it really nice for small projects. But when the project starts to grow and you need to do like heavy refactoring, heavy modifications in your code, this is where the nightmare starts. I do use Python. I do use Python for very small projects, very small code, small functionalities. But yeah, since when I need very big projects, I don't go for Python. I think it's just like the way I see programming languages is like tools in a toolbox, you know, and every tool is designed to do some tasks. And for me, the Rust tool is not actually addresses like a huge range of stuff you can do. Python is one usage, C is one usage, and Go is one usage, and both comes with, I mean, all of them comes with their own limitations. Rust as well comes with these limitations. It's hard to learn. It's sometimes a bit like heavy just to do some small tasks. So, and I mean, for me, this is just a matter of accepting and knowing where you need to use which. And for me, I would never go again for big projects in Python because this was really, really a nightmare. It's a nightmare for imports. When you want to install, then it's a nightmare. You get issues with dependencies, refactoring. You refactor something, it explodes everywhere, or you realize that 2 months after you introduce a bug, but
I think like after dealing with a lot of tech debt, you start seeing the philosophies behind different computer languages, like dependency issues in Python and JavaScript, for instance. Like if you still understand the philosophy of where to use this, then those issues are also like a bunch of freedoms that people can really like move around freely. But then, like you said, if you want to do something like a backend that you do it properly, plan everything and so on, and test it, and then you don't want people to go back and change libraries and so on, then it's better to see it that way. So yeah, I think the human factor is also important, like how developers, if you release a bunch of Python developers to do front end, for example, it they might not adapt the philosophies that are better for front end and vice versa.
Yeah. Yes.
Your experience.
About
the use cases for us. So if there will be need for me in the future, then there are some needs, of course, to develop some system tools to solve some, let's say, prepare some statistics maybe, or analyze some data. I would go with Rust to try it at least.
Yeah.
What are you see the usages of the language? So it's not the web application, it's not, okay, Python also has a lot of wide range, so perhaps you said for people.
So what I actually like with Rust is that you really cover a huge range of applications. I mean, you can develop from kernel, you can develop UEFI bootloader, you can develop like from the bootloader until web applications if you want. So this is like huge like range of applications in Rust that you can implement. The only thing I couldn't recommend implementing in Rust is, as I said, is like reactive graphical front end, which I think it's much more convenient with TypeScripts and JavaScripts and so on. But all the rest, I don't see any like objection not to go for Rust. I mean, maybe, okay, if it's like something you can solve in a 10-line bash or 10-line Python or even 100 lines Python, so 100 lines bash, yeah, doesn't need to trigger like the Rust software for that. I mean, a Rust development stack for that. But definitely any kind of projects can be in Rust, and I don't see like any objection or saying don't use Rust for that. I mean, I think Rust helps you like saving a lot of time. It takes time to learn, but once you learned it and you really develop your everyday programs in Rust, it goes super fast to do tasks. But again, the entry cost is huge, is high, but in the end, it pays off. So
the maintenance of the projects that are developed on Rust, it's super easy as I understood, the maintenance. Like when Python needs to, when you update something, deploy a new version, that you can face this package is not available anymore on pip or it's used. So we need to, okay, check this version, and then it's another version that perhaps doesn't work. You updated your project, but some changes introduced in the new version, you blindly, okay, it recommends me, or it says like I have to update, or it's a limit, I cannot deploy my project. And then you update it, and you deploy, and finally this version is not compatible with what you wrote. So it's with Rust you don't face such.
No, I don't think so, because there is this mechanism such as with Node application and so on. You have like a package locking, which has like specific version and commit of the package you are using. So and most of the packages that you are going to use are fetched from crates.io. And crates.io, it's basically where all the Rust packages are published. And there you cannot like just remove one package. This is, you can only if your package has been downloaded less than 100 times or 1,000 times. So this is absolutely almost impossible that something you are using and which is working with your project just disappears like that. This is impossible.
It's not disappearing. It's the new version that is not. But I guess if there is a change in the package that you use in your code implementation, you use some I don't know, library that provides you documents reading or generation of PDFs or whatever, and then they made a major change, abandon some deprecated stuff, and then there's a call. It will be your application because it's compilable language. It will not be compiled.
But no, there is
difference between Python because it's runtime.
Basically, yes, there is this version and version locking for all your packages. So
that's also for every language version locking.
But so it should not be an issue for Python, right?
There is no, I mean, you update version. The locking, you update it, but you didn't know that there is a change.
You mean you make an upgrade and but this happens as well in Rust. If the project is not well managed, then sometimes it doesn't respect because there are rules, you know. In theory, when you do patch release, you should not break APIs. If you do like a minor release, okay, you can accept to have some APIs broken. So if you respect like the way of versioning of your software and so on, it should not work. But I mean, this is not guaranteed. This is up to the developer to actually enforce this this kind of versioning, proper versioning. I mean, I'm using one project, and it's been 2 times that they break API on patches change on patch upgrade. So I'm there to tell them, and they revert and they fix the stuff. But it can happen, I think, in any language, and it's completely independent from the programming language. It's just the developer doing weird stuff with their versioning policy and the way they release code. So I think this cannot be fixed by, you have to fix humans for that. Don't fix the programming language, but.
I think the huge advantage that is overlooked is that it feels like Rust is basically Python plus unit tests. So it's actually comparing Python development time to Rust is not entirely fair, because with Rust you get type safety and so on that you would normally have to test on Python side.
Yeah, and it depends what, because Python comes with a lot of limitations through like multi-threading is like a hell. It's super hard to manage. It's super slow. There are a lot of places where you cannot basically run Python. I mean, everything which is below userland, you cannot run Python, of course. So yeah, there are lots of limitations associated to every programming language. And what I like in Rust is that you have this wide range of applications that you have. It's basically one language where you can do a lot of things. So if like one student would ask me what programming language should I learn, I would highly recommend this one, because This is no, not Java. Yeah.
Java is good for discovering OOP, I think.
Pardon?
Java is good for discovering OOP.
Yeah, but OOP seems to be dead now.
I don't know.
It seems dying, yeah, because
this is the only usage I can tell for
because
Java.
yeah, modern programming language tend to get away from OOP. So maybe I don't know. It's like, you know, a trend. Maybe in a couple of years it will surface again. So, but I would say that the actual tendency is rather go away from OOP, because I mean, Go like completely moved away from OOP, and Rust too. I don't know for the other modern and recent programming languages, but yeah, it seems everyone considered like a lot of stuff in OOP are just useless and most of the time badly used.
Yeah, this is the case. When it's badly used, this is the danger.
But you put everything in one big object.
Yeah. But I think, yeah, Rust couldn't even have like with all like the concepts it's bringing, it introduce, it cannot like have OOP patterns, because a lot of stuff in OOP relies on casting, on transforming objects at runtime, like considering one object is something, then it can be changed to something else, and so these are stuff which are just impossible to do in Rust. So they kind of had to deal with that. But if you happen to actually develop in Rust, you will realize that doesn't matter. You are able to do what you want to do. As I said, the only issue that you may face is just see the things differently. Just try to implement stuff in a different way. But in the end, when you get used to it, not a big deal. It hurts the first times, and after that, it's okay. 2 or 3 nights you don't really sleep well. You think about how to implement your doubly linked list, and then you find it and you do it, and it's okay. Yeah, because many things. I mean, one thing we haven't seen is like how can we deal with such structures such as a doubly linked list, which should point to other stuff. This is a bit a challenge in Rust, because with all the lifetime and so on, that should be controlled. I didn't spend too much time on this because, to be honest, this is something, it's been like maybe 3 or 4 years I'm doing Rust. This is maybe something I had to implement or to use twice. So this is not like something you need to use a lot. If you are facing such an issue, don't worry, there are solutions. And again, after we finish this training, I say it again, you should absolutely take a look at the Rust book, because we just covered like a little portion of what we can do with Rust. Was just like to give you some taste and to understand basically the bigger concepts behind the language, so that you don't get in front of something and you are completely lost. Was just to give you like foundations, but you should definitely take a look at the Rust book and at least know what it talks about, what you can actually do, and yeah, maybe other stuff I didn't mention, because the Rust book really is really exhaustive. So yes. So we can do final session on Monday with maybe more cool approach where we address your issues, and where maybe we just kickstart with project creation and stuff like that. More, let's say, project oriented rather than programming language oriented. And we will be good.
Monday, 10, right?
Yes, but it's going to be remote because all the rooms at LHC are taken. So maybe myself, I will go in a small podcast room or whatever, so that I don't annoy my colleagues in my office. But yes, we will have to do it remotely because no room available on Monday. Something important with Swiss Life.
How many places there, you think, can join there?
We're in the room. I don't know. I've not booked yet, so I don't know.
Between 0 and 4.
Yeah. Will be between 0 and 4. Yeah. So podcast room, I guess, has 4 spots. I will see.
If we continue the tendency since the beginning of the first Rust lang, you should be 4.
Yeah, maybe at the end we are 4.
I think we might have more. There's some people that missed out.
Yeah, true. So yeah, and again, if you decide to start a project in Rust, don't hesitate to ask me. I will be happy to help and to guide you into a, let's say, a smooth path rather than having lots of issues.
The Rust book, is it just that site, the dark dots?
Yeah, it's rustlang.org, something like this.
Yeah.
That's a good by itself. Rust, for example.
Yes, this is this is this.
Because they also.
But at least three different.
Yeah, this I guess it's the paper version. Yeah. This is the same stuff, but paper version. To be honest, I did like the online one, and it's okay.
Yeah, just saying.
Like, I did like 1 chapter per day for 1 month.
Okay.
But believe me, if you do more, you are going to have your brain fried.
No.
But
that's the idea.
I hope less than I did, because I mean I had like no previous experience with Rust, so you should already have some understanding of what you are reading. But
yeah, you should buy a bunch and put them in the restrooms.
Yeah.
The no restrooms you have occupied forever.
And we will call that the Rust room.
Yeah. There we go.
And what did I want to say? And yes, there is something very nice that I mentioned in the README of that training, which is a project called Rustling. And Rustling is actually dividing exercises based on the same chapters as the Rustlings. There you have it. It's dividing like in the same chapters as the Rust book, and these are actually small exercises you have to do at the same times as you read the chapters. So these are very nice. Most of the time, these are just pieces of code that you need to fix, and that's very nice. That's something very nice.
This Rustling course.
Yes. So Rustlings plus the Rust book, and again, don't need to read everything. You should be able already to understand like a lot. Oh, sorry. But yeah, only thing you have to do if you really want to continue that learning Rust is commit to do at least 1 project. And if you don't do that, you will have to learn Rust again. That's what I did. Those guys know because I posted it in our chat, but I actually learned Rust 2 times. And this is not something you want to do. I kind of learned it once. I almost read all the books and I did one small project. Then I didn't use Rust for 2 years and then I forgot everything. So, and yeah, the first project I did was really, really small, just dealing with some files, some IOs and so on. So yeah, basically didn't use the language enough to remember stuff. So if I can prevent you from doing the same mistake.
So Rust thing, it's a tool that we have to install, right?
Yes, this is it comes with the binary, I think, and this is like a bunch of Rust files, and it compiles like the exercises as you go through, I think.
And your exercises that you created, learning material, you created by your own, or?
Yes, some of them I think I've taken from the Rust book. Some I've written myself, and I cannot tell you. To be honest, I don't remember which one. Some of them I just inspired from the Rust book, and but no, in majority this is not like stuff I copy pasted from somewhere. I think it's good. I'm gonna stop the recording and the presentation. I think Andrea, you are the only one remaining, the Highlander.
Yeah. Also, Christian.
So thanks a lot. And pardon?
Christian is there also. He's here.
Yes, but Christian is in the room as well. Christian
Okay.
is just for recording. That's why I don't mention him.
Okay.
So thank you, Andrea. I'm gonna stop the meeting and stop the recording.
Thank you.
Cheers, and see you on Monday if you are here.